Right, we want to calculate the value of the unknown. We want to find the value of theta in A. So we start by writing the solution to 2A. And therefore, to find the value of theta, we proceed as follows. First things first, we realize that opposite vertex B is B, this one opposite A is A, and this one is surely C. And therefore, C squared is A squared plus B squared minus twice AB cosine of C. Right, so which means we have C squared equals the A, which is 16 squared plus 30 squared minus 2A 16 B 30 cosine 28 degrees. So as a consequence, which means C squared is equal to 308.37031. C therefore becomes the square root of 308.37031, and the square root, obviously, if this is approximate, so the square root of this is approximately 17.56 units. Okay, so which means the length of C is approximately 17.56 units. Right, so with that being said, we proceed to find the value of the unknown theta. So to find the value of theta, we proceed as follows. Right, so that would be the sine. So we're still looking at 2a. Right, so it will be the sine of theta divided by 16, which is equals to the sine of 28 degrees divided by 17.56, and this is the sine of theta, which equals 16, the sine of 28 degrees divided by 17.56, and this means the sine of theta is, if you use a calculator, this is 0.42776, and what this means is therefore theta is arc sine of 0.42776, and therefore so this is quite approximate, and therefore theta is approximately 25.33 degrees. All right, so our theta here becomes approximately 25.33 degrees. Okay, so that's what we get here, and then we proceed to do the next one. So we found out on theta the unknown angle of theta in A, and therefore now we're going to proceed to find the unknown angle theta in the next diagram. Okay, in diagram 2b, and so to do that, we first have to realize that we have this side here, this side here. We just need to find this side here, because if we find this side, we have three sides and one angle, so we shall be able to use the cosine rule in that shape. All right, so we proceed as follows: twice b. All right, so we're looking at question 2b, and in 2b we realize that obviously we need to find this side here, QS. So we can clearly say in triangle PQS. Right, so in triangle PQS, what we have in triangle PQS, we have QS over, so this angle here, angle P is going to be 180 degrees minus 15 degrees minus 26 degrees, and therefore it is 139 degrees. Okay, so this becomes in triangle PQS, we have QS over the sine of, okay, let me just do this. Let me load the shape again. Okay, let me just load the shape again. there, or just proceed with the shape. Okay, right. So in triangle PQS, there, so we have triangle PQS. I want to just have the triangle drawn here so that we are able to visualize what I'm talking about. Otherwise, it will just not make sense. So we have 15 degrees here. This is 139 degrees. This is 26 degrees here. This is P. This is Q. This is S. Okay, I'm just looking at that triangle there. Okay, so I'm looking at actually twice B. I want to find QS, or I will say in triangle PQS, QS over the sine of 139 degrees, which equals so now this one is 100. Okay, so it is equal to exactly 100 over the sine of the opposite angle, the sine of 15 degrees. So that is QS. So QS is 100, the sine of 139 degrees divided by the sine of 15 degrees. And therefore, if we simplify this and get the result, that means QS is 253.4817 full units. Okay, this gives us exactly the length of QS. Okay, after we found the length of QS, we know that is 253.48 units. So if this one is 253.48 units, okay, it remains to just find now the angle theta. So we're going to work in triangle QSR. So now the next thing to do is to work in triangle QSR. Right, so we have this triangle here, and this is Q, and this is S, and this is R. Right, so this is 253.48. This angle is actually obviously theta there. Right, so we just need to find the angle theta. This is 102 units. This is 243.5 units. And therefore, we need to find the angle theta. So we told the examiner that in triangle QSR, we have that we can use the cosine rule here. So which means that 253. So if you want, we can do it like this. Okay, we can just say opposite angle S is lowercase s. Okay, opposite this one is lowercase q. This is R. So which means R squared is q squared plus a squared minus 2qs cosine R, which means R squared is 253.48. And then Q is 102. And then S is 243.5 minus 2Q is 102. And then S is 243.5 cosine theta. Okay, so that is what we have there, cosine theta. All right, so we continue with the work. We attempt to simplify this. All right, so if we simplify this, then it becomes cosine theta, and cosine theta, and therefore it's going to be 102 all squared plus 243.5 all squared minus 253.48 all squared. You divide everything by 2 into 102 into 243.5. Okay, so we have this, and if you simplify this is in calculator, we get 0 point. Okay, we get 0.10959, and then we are able to find arc cosine, which is 0.10959, and this is exactly 83.708 31 degrees. Okay, so that is the angle of theta, which is 83.708 degrees. So we go back to the shape here. So this angle here is approximately, okay, it is approximately that one. So it is approximately 83, right? So it's approximately 83.70831 degrees. That is the angle, and that is exactly the unknown there. And we can even come here and say, okay, Mr. Examiner, this angle you asked us to find, we have just got, and it is 83.70831 degrees, and that is the answer. So we got the angle theta here, we got the angle theta there. Thanks everybody, a goodbye to you.